Good morning, CSEC students. Welcome to another live class. This morning, we're going to be continuing our class from yesterday where we're looking at solving simultaneous equations using the method of matrices. Now, when we talk about solving simultaneous equations, there are a number of methods we can use to solve them. Now, when we talk about using the algebraic method, we can use the method of elimination. We can use the method of substitution to solve the simultaneous equations. We could also use the method, the graphical method of solving simultaneous equations, whereby we plot both functions, both equations on graph paper, and we see where the graphs intersect. So the two graphs, the two functions plotted on the same graph paper, and where those two graphs intersect. So whether it's two linear equations or it's a linear and a quadratic, we would see the intersection and take our readings on the x and y axis, and those would give the solutions for the simultaneous equations. So what we're going to do now is to use the matrix method. All right, so a number of methods: algebraic, the graphical method, and we're looking now at the matrices method. When we're using matrices to solve simultaneous equations, we first must find the inverse of the matrix. And the inverse of the matrix is 1 over the determinant times the adjoint. So we're going to go step by step. And the first things first, though, you're given the two equations. So, for example, 28x minus 5y is equal to 3. 4x plus 2y is equal to 14. So these are our two equations that we are asked to solve. And when you're solving simultaneous equations, remember, the reason they're called simultaneous equations is because you have two unknowns, two variables, and usually as well two equations that you're trying to solve. So you're solving two different equations with two different variables, and you want to find the value of each variable. So what is x, what is y? Or remember, other letters can be used to represent the x and the y, to represent the unknown, sorry. Any variable can be used, w, p, q, r, even a symbol, an asterisk, a triangle, whatever it is. So the first thing that we do is we rewrite the equations in matrix form. So now they're in the algebraic form. And if we had been given these two and asked to solve them using algebra, we could use the elimination method. We could use the substitution method. So we're going to put them in matrix form. So we'd have 28 negative 5, 4, 2, and we're going to write xy equals 3, 14. Now we're going to find the inverse, and the inverse is 1 over determinant times the adjoint. So what's the determinant? The determinant is a times d minus b times c. So it's a, b, c, D. So the determinant is 1 over A times D. So 28 times 2 minus B times C. So minus -5 times 4. And that's going to give 1 over 28 times 2 is 56. And negative times negative is positive, so that's positive 20. So that gives 1 over 76. That's the determinant. And we're going to multiply that by the adjoint. Now the adjoint is to switch places with the A and D. So the 2 would come here. The 28 would go there. And we're going to change the sign of the B and the C. So this would now be a +5 and a -4. So this is the inverse. 1 over the determinant times the adjoint. So what we're going to do now to solve the matrices is we're going to multiply the inverse by the answers that we have over here, and that will give us our x and y value. So we have, right back our inverse, 1 over the determinant times the adjoint times 3 over 14 would give x and y. So what we're going to do is we're going to retain the fraction and leave this part for last. And we're going to multiply the matrix by, so the 2 by 2 matrix by the 2 by 1 matrix. So 2 times 3 and 5 times 14. -4 times 3 and 28 times 14. Equals x, y. Still retain the 1 over 76. So let's work this. So 2, 3 is 6. 5 times 14 is +70. -4 times 3 is -12. And 28 times 14, that's 392. So +392 equals xy. So 176. 6 plus 70 is 76. And -12 plus 392, that's 380. So finally, we're going to multiply the 1 over 76 times each of these to get our x. The top value will give us the x, and the bottom value will give us the y. So x would be 1 over 76 times 76, which is 1. And y would be 1 over 76 times 30 times 380. And that gives 5. So x is 1 and y is 5. And if we plug those values back into our original equation, so 2 times 1, 28 times 1 is 28, -5 times 5 is -25. So 28 minus 25, that's 3. 4 ones 4, 2 5s 10, 4 plus 10 is 14. All right, so that tells us that our answer is correct. So remember, whenever you're solving equations, whether simple linear equations, quadratic equations, simultaneous equations. When you get your solution or solutions, plug them back into the original equation or equations, in this case, two equations, and see if they make sense. So that's how we check if our values are correct. So let's work another example. We're going to work 5 examples today. So we have 3x plus y, and that gives 13, and 5x plus 3y, and that gives 31. So this is our original, these are our original equations. Okay. So we know that we need to find the inverse. So let's rewrite the algebra in matrix form. So that's 3, and this is a 1. The coefficient is 1. That's 5. That's 3. And this gives 13, 31. So now we're going to find the inverse, which is 1 over the determinant times the adjoint. The determinant is A times D minus B times C. So it's 1 over 3 times 3 minus 1 times 5. And that's going to give 1 over 9 minus 5, which is a quarter. And we're going to multiply that by the adjoint, which is switching the A and D, but they are the same. So, and changing the sign of the B and the C. So the positive 1 and positive 5 become -1, -5. So we're going to write the inverse now. A quarter, 3, -1, -5, 3, 13, and 31 equals xy. So we retain the fraction. You could work these two first, but you'll end up with 4 fractions in here to work with that. So I prefer to leave the fraction, and usually 1 over the determinant is a fraction, unless you get 1 down here, which will give you a whole number 1. But other than that, you're going to have a fraction. So just work the whole numbers first. That's my advice. 13 and -1 times 31, -5 times 13, and 3 times 31. Three times 13 is 39. -1 times 31 is -31. 5 negative 65, and 3 times 31 is 93. So we have a 39 minus 31, that's 8. And negative 65 plus 93, that's 28. So we have, so the top value will give us our x and the bottom is 2. So x is 2, a quarter of 28 is 7, so y is 7. And to check if our solutions are correct, we can plug those values back into the original equations. So let's see. So if x is 2 and y is 7, so 2, 3, 6 plus 7 is 13. 5, 2 is 10, plus 3, 7 is 21. 10 plus 21 give 31. Okay. So we're going to do a couple more for good practice. Maybe about 3 more. And by then, you should be quite versed in solving simultaneous equations using the method of matrices. All right, so the third, this is a pretty simple one. So x minus y equals 14, and 5x plus 2y equals 28. So that's the original equation. And let's write it in matrix form. So we would have 1, the coefficient of the x is 1, coefficient of the negative y is negative 1. And we would have 5 and 2. X, y. And we would have 14 and 28. So it's 1 over the determinant times the adjoint to find the inverse. The determinant is a times d, so that's 1 times 2, minus b times c, so that's negative 1 times 5. And that would give 1 over 2 plus 5. So that's 1 over 7 times the adjoint, which is to switch places with the a and d. So the 2 comes here, the 1 goes there. Change the sign of the b and c. So that the negative 1 becomes positive 1 and the positive 5 becomes negative 5. So this is our inverse, and we're now going to multiply the inverse. So it's 1 over 7, 2, 1, negative 5, 1, times the 14, 28, and that will give us x and y. So keep the 1 over 7 to the last. 2 times 14, 1 times 28, negative 5 times 14, 1 times 28 equals xy. And the 2 times 14 is 28. And 1 plus 28 is 28. 1 times 28 is 28, sorry. Negative 5 times 14 is negative 70. 1 times 28 is 28. All right. And that's xy. So 28 plus 28 is 56. And negative 70 plus 28, that's negative 42. So finally, we're going to multiply each of the terms in the bracket by 1/7. So 7 into 56 goes 8. So the x value is 8. And 7 into negative 42 goes negative 6. So the y value is negative 6. And plugging in those solutions into the two equations, so we would have 8 minus negative 6, which is 8 plus 6, that's 14. 5 8 is 40. 2 times negative 6 is negative 16. 40 minus 16, sorry, 2 times negative 6 is negative 12. 40 minus 12 gives 28. Next equation, 2x minus y is 19. And negative 3x plus 2y, that gives negative 29. These are our original equations. Let's rewrite them. In matrix form. So put in the coefficients. So that's 2, negative 1, negative 3, positive 2, xy equals 19 and negative 29. No, to find the inverse, we need the determinant times 1 over the determinant times the adjoint. So 1 over 2 times 2 minus negative 1 times negative 3. And that gives 1 over 4. This makes it negative. So that will be minus 4. All right, so that would give 0. Let me double check if I have the correct thing. So it's 2x minus y is 19. Negative 3x plus 2y, that's negative 29. So we have 2, negative 1, and negative 3, 2. 2 2's 4 minus negative 3, negative 1. All right, so this is going to be 0. 2 9s, 18. Negative 27 minus 2. All right, so we're stuck here because the determinant is giving us 0. So I don't think we solve it using the matrix method. So I'm going to double check one last time. We have 2x minus y, that gives 19, negative 3x plus 2y, negative 29. All right, so the coefficient is 2, negative 1, negative 3, positive 2, d minus b times c. So 2 2s, 4, and negative 1 times negative 3. I went wrong. All right, so this should be 3. All right. All right, so negative 1 times negative 3, so that would be 3. So it's 1 over 1, which is 1. All right, so that's 1 times the adjoint A and D, and change the sign of the B and C. All right, so now we're going to multiply the adjoint. Okay, so all right, so I'm seeing where my scholars were correcting me here, but I was looking at the chats just now. All right, so thanks for that. All right, so let's continue. So we don't even have to put the 1, but let's put it. So 1 times 2, 1, 3, 2, and 9, negative 29. All right, so that's x, y. All right, so we don't have to put the 1 here. So what we'll have is 2 times 19, 1 times negative 29, 19, 2 times negative 29. And that will give x, y. Okay, so 2 times 19, so that's what, 38 minus 29. And 3 times 19, so 3 nines, 27, that's 57 minus 38. No, sorry, that's 58. Okay, equals xy. 8 minus 29, that's 9. And 57 minus 58 is negative 1. Therefore, x is 9 and y is negative 1. So plugging in those values, so 2 times 9, that's 18, minus negative 1, that's 19. Negative 3 times 9 is negative 27. 2 times negative 1 is negative 2. So negative 27, that's negative 29. All right, so let's do one more for the road. All right, so it's always important if you run into what seems to be a roadblock, just go from the beginning. So retrace your steps, go back as a mathematician, prepared to do that over from scratch and follow the steps and see where you overlooked something, where you missed something. All right, so the last one. So we have 3x minus 2y equals 10, and negative 6x plus 2y equals negative 28. All right, so that's the original equation, and we're going to put it now in matrix form. So the coefficients of the variables, so that will be 3, negative 2, negative 6, and positive 2. And we'll have x, y, and 10, negative 28. So the inverse will be 1 over the determinant. And the determinant is a times d minus b times c. So that will be 3 times 2 minus negative 2 times negative 6, which is 1 over 6 minus 12, which is negative 1 over 6. The adjoint would be to switch places with the a and d and to change the sign of the b and c. So now we're going to multiply the adjoint by the matrix. And we're going to get our solutions. Okay, so let me use yellow. So it's negative 1/6 2,263, and we have 10, negative 28, xy. So retaining the negative 1/6, and we'll have 2 times 10, 2 times negative 28, 6 times 10, 3 times negative 28, and that's xy. So negative 1/6, 2 times 10, that's 20, 2 times negative 28 is negative 56, 6 10s 60, and 3 times negative 28, that's negative 84. All right, so let's see what this gives. So negative 1/6. 20 minus 56, that's negative 36. And 60 minus 84 is negative 24. So negative 1/6 times negative 36, that's going to give a positive 6 for x. And negative times negative 24, that's going to give a positive 4 for y. So plugging in those values, for x is 6, y is 4. 3 6s 18, 2 4s 8. So we have negative 8. So 18 minus 8, that gives 10. Negative 6, negative 36. 2 4s 8. Negative 36 plus 8 gives negative 28. So always remember, when you have your solutions for your equations, whether simultaneous or straight linear or quadratic, substitute those values back into the original equation or equations and check to see that they add up, that they make sense. Okay, so that's it for using simultaneous, using matrices, using the matrix method to solve simultaneous equations.